Hello Internet, I'm Remote Leg, and welcome to the LifeStyles project, a study of A-Life. I added the sun! Let there be light. Look at this little puppy orbiting high above our virtual world. Isn't it lovely? I'm very happy with how it turned out, and it was surprisingly simple to implement. Well, we can't actually see the sun because there's no feature to render it, but we can see its footprint of heat and light on the world's surface. Every cycle, the sun dumps energy into the world. This map is showing energy, and the white light halo around the heat shows that light travels faster than heat, so it flows further. This is shown in the dissipation values for light and heat. Also, light transmutes into nothing almost immediately, which is why only heat has a lingering trail because it takes longer to fade away. The final effect is very pretty. Very happy with this. Here's how it looks under the hood. These values are all constants because I never need to mess with the sun once it gets going. I just set it up and give it a little push. After that, it's on its own. The value Sun Y range says that the sun will cover 2/3 of the world's surface in its orbit. Of course, heat and light travel further, so the poles actually get some energy, but only in summer. The next value, default velocity x, defines the west to east speed, and this formula means that there are 48 cycles in a day. These next four values define the light and heat footprint that the sun generates on the surface. And that's it for the values I can change. I can tweak the sun just by modifying these 6 values at the top. Of course, all this means one important physical law. The sun orbits the world, not vice versa. Also notice that substances and creatures are stopped at the north, south, east, west boundary edges, but the sun travels all the way around the world. The statistics report now has a sun report added to it. The map has a new display type that shows the visible surface of the world, both solid and liquid. See the erosion near the coastline? I can see sandy beaches. Also, I can now click anywhere on the map to get the location report. This is easier than typing the coordinates each time. I need a way to rescale the map. If I get the map to show solids, we see lots about. But the quantity maps for each of the solids show only faint outlines here and there. I need to get the map to adjust its upper limit, that's the quantity that shows in brightest green, to correctly display lower ranges of substances. If the maximum amount of sand at any location in the world is 20, that should be shown in bright green. But if the maximum is 500, that should be bright green, and the quantity of 20 should be shown much dimmer. The energy generated by the sun is boiling liquids into gases and creating rain. But it's hard to see if that's working properly. Time for some more map features, I think. Done. Dissipation was a decimal number from 0 to 1 that defined how quickly substances flowed from one location to another. I changed that to an integer that defines the maximum amount of a substance that will flow. It sounds complicated, but it works better. Water still flows from high locations to lower ones, and a greater altitude difference will result in more water flowing in a particular cycle. This dissipation figure says that a maximum of 25 units of water can flow in any cycle. This is a hard limit. So water can flow from one location to another as a trickle up to a torrent, but it's limited to a maximum of 25 units of water in any one cycle. Think of it as a measure of viscosity. Higher numbers flow faster. Solids work the same way, but they still need flowing liquids to move them via erosion, as I mentioned in an earlier video. Gases work the same way too, but they use pressure instead of altitude to decide how much to flow. So the visible surface map shows the solids boiling into liquids as the sun passes overhead. If we look at rainfall, we see the red evaporation of liquids into gases during the day, followed by a long trail of green rainfall as those gases cool in the early evening. This rainfall causes a slight pressure difference, and this helps to disperse the clouds before they turn to rain. And here we see the wet ground after the rains have come, and the scorch marks across the world's surface where the solids have boiled away. If you look at the heat trail of the sun, you can even see the faint plumes where heat is released by gases cooling back into liquids. Excellent! The statistics report shows how the amounts of substances have changed as everything boils and freezes, all due to our little sun passing overhead. Now, I just need to do some fine-tuning before I add some creatures. They won't survive in a world where the surface boils away during the day and rains down in the evening. I need a world where liquids cover a lot of the surface, interspersed with dry patches. Perhaps I'm being biased because that's what our world looks like, and I think it makes for a pleasant environment. What I really want is a good mix of substances, so the creatures have lots of choices as to what substances they want to exploit. A world composed of boiling lava or hard permafrost doesn't sound very inviting, so I need to tweak the sun, the transmutation and the dissipation values to get the heat balance just right. Back into it. Really happy with how my little sun turned out.